Hello everyone. Today I am going to be talking about inverse functions with you guys. So, let's start. So, let's analyze the function 3x plus 1. Now, you may or may not know, but this is, let's look at the properties. It's just a linear function, meaning it's a line. Okay, and we know it's a function, right? We know it is a function, but what type of function? That's what I want to start off with. What type of function is it? And since we know it's a function, what type of function? There are two types of functions. There's one that's called one-to-one, and I'll explain what that is, and more-to-one. Okay? See, the thing is, not all functions have inverses. Not all. And the only functions that do have inverses are one-to-one functions. So they have inverses. Alright? So we want to make sure the functions we are going to be analyzing, that they are one-to-one functions, right? So they have valid inverses. Now, how do you know what function is a one-to-one and which one is not, or is, otherwise known as a more-to-one? The only way, so hold on, let's graph this little thing. Just roughly, we know it's a line, and the 1 brings the graph up 1, so it's your y-intercept, and the 3 makes it a little steep. Okay, let's say it looks like that. Alright, so how do we know it's a one-to-one? Well, the way to find out whether a function is one-to-one or more-to-one is through, is through the horizontal line test. And I know, what in the world am I talking about? I know. This is how you may perceive it as. You just have to draw a horizontal line along your function. Okay? You can make 1, 2, or 3, or 4, or an infinite amount, but there's a reasoning to this. Okay? So let me just draw some horizontal lines across my function. This will be just straight horizontal lines. And what do I achieve by this? Well, what you now have to check is whether your horizontal line touches your function once or more than once. So we can see, let's look at this line right here. This line touches this function once, right there. Correct? Let's look at no, I didn't make that line. This one. This function touches our graph once. This one touches our graph once, and this one touches our graph once. The graph is right there, by the way. Okay? So what does this mean? Since it touches the graph once, this means this function, 3x plus 1, is 1-to-1. Okay? And since it's 1-to-1, that means it has an inverse. So great. And more-to-one is an example of more-to-one is a normal parabola, so x squared, for example. If you always have to check which function it is, you have to make a horizontal line. So make it pass the horizontal line test. But look at this. Now the graph touches the function, the line touches the function 2 times. Uh-oh, that's not good. Same here. Right? And since it touches it 2 times, it's a more-to-one. We don't like those. Well, in regards to inverses. Okay, so we want to be working with one-to-one functions. So that's the dealio with that. And now that we know y equals 3x plus 1 is a 1-to-1, we can easily find the inverse of it. But hold on, we still need to understand what an inverse is. So let me just write our function here. So if we make a table of values for this function, right, just plug in x and x's to get our y's. Let's do let me do 0, 1, 2, and 3. Plug in a 0, 3 times 0 is 0, plus 1 is 1, 3 times 1 is 1, plus 1 is 4, 2 times 3 is 6, plus 1 is 7, and 3 times 3 is 9, plus 1 is 10. Okay, so what are we doing here? We are plugging in x values in order to get our y's. Okay, so let's take an example. Let's take this example. We are plugging in a 2 into our function, and we are getting out a 7. So we're going from x to y, right? From 2 to 7. But the question right now is, can we get a 2 by plugging in a 7 somewhere? Can we do that? Can we plug in a 7 into some function, we don't know what this function is, and get a 2 as our answer? Okay, so really you're plugging in a y and getting an x. Like you're working backwards. You plug in an x here and get a y. Here we want to know if we can plug in a y and get our x. Okay, so we want to work backwards. How can we do that? Well, in order to find this function that lets you do that, we have to find the inverse of this original. This is the original, we want to find its inverse. That's what, inverse. Okay? And that's what we are going to do. And there are just 2 easy steps to doing that. That's really it. And I'll show you how to do it. So, let me just write that again. 3x plus 1. The first step is to switch the x's and y's. What do I mean by that? This means wherever you see a y, put an x in. Wherever you see an x, put a y in. So, because we want to work backwards, so we have to switch our x and y's. So if we do that, we get x equals 3. We have an x, let's plug in a y plus 1. Alright, that's the first step. The second step is to basically solve for y. Make y by itself. So move all these crazy numbers to this side, okay? That's what we have to do. Solve for y, and let's do that. So first I'm going to subtract a 1 here. So move this 1 on this side, and I get x minus 1 equals 3y. Right? And I want y by itself, so I'll divide by 3. And so y equals x minus 1 over 3. Oops. And guess what this is? This is our inverse function. Now the notation, so we said our original function with f of x equals 3x minus 1, right? That's what it was. No, it was plus 1. I knew it was doing something wrong. F of x is the same thing as y, so it's the same notation. We got our inverse, x minus 1, 3. The notation for an inverse is this. This minus 1 exponent, you might think, but it's not an exponent, it's just a notation. So you can differentiate this and that. Okay? Is x minus 1, 3, over 3. But we need to test it. How do we test it? Remember we said in our original function we plug in a 2 and we get a 7? Our goal was to plug in a 7 somewhere to some function and get a 2. So we found some function. Let's see if it does the job. Let's plug in a 7 and see if we get 2. So if we do f of negative a 7, if we plug in a 7, so 7 minus 1 over over 3. 7 minus 1 is 6 over 3. And this is 2. So, guess what? It does the job. This means that we found the correct inverse, okay? And we're all happy, right? If everything works in math, we're always happy. So that's really it. These 2 steps, and then just change your y to f of this minus subscript thing, negative 1x, and write your function. And that's your inverse, okay? Yeah, but there's another, okay, maybe I'll do it in my next video. I want to show you how to find an inverse of a function. I'll work with the same function graphically, okay? So if you don't like doing this whole algebra work, although it's fairly easy, you can do it graphically. And I'll do that in my next video. Thanks a lot.